Now there's two variables. But notice each variable part contains a power of m and a power of n. Okay? So let's kind of treat this the same way and see if we can get a result that makes sense. Look at the 15, the 30, and the 25. What's the GCF of 15, 30, and 25? 5? Okay. Now just look at the base m. You have m to the fourth, m to the fifth, m cubed. M to the third, take the smallest power of m. And then multiply it times the 5 to help form your GCF. There's one more base in your GCF, base n. You have n in the first term, you have n to the first power, second term n squared, third term n cubed. Which one do you take as a factor in your GCF? N to the first, so just n. So 5m cubed n is your GCF. Does everybody see that? So you just go, you look at the coefficients first and then go each base, take the smallest power of each base to base m, base n in this case, to form your GCF. Is that easy enough? Okay, now I think this part's harder actually. What's left? It's not that it's harder, it's just easier to make a mistake here. So what's left from the 15 m to the fourth n if you factor out 5 m cubed n? 3 m, there's still one factor of m left, right? Because you only factored out m cubed, but then you factored out the n. So that's not going to show up. 3m for the first term inside the parentheses? Okay. Plus what? 6. Does everybody see? You take out a factor of m cubed, it's m squared that's left. And then there is a factor of n left because there is n squared to begin with. Make sense? Okay, what about the next guy? 5. Okay, we took out a factor of m cubed, so that guy's gone, and then we took out a factor of n, which leaves n squared. Could you check that by multiplying it out? Realize you always can do that. So multiply it back out, and you'll see you get exactly what you started with. Okay, any questions on factoring out a GCF? Old stuff, right? I'm hoping? Yeah? Okay. There will be times when you want to factor out a negative number or a negative quantity. So let's factor out the negative GCF. So in other words, treat this like the other problems, except instead of factoring out the positive GCF, slap a negative in front of it. So what would the negative GCF be of the polynomial with negative 2x squared plus 4x to the fourth minus 12x cubed, with those guys as your terms? What would okay, well, what about the constant part? What would you factor out? Well, okay, but that's right. If you were just going for the positive GCF, as usual, it'd be 2. But here, what are we going to do? We're going to make it a negative 2. Now, remember what that's going to do. That's going to change the sign of each term when you factor out a negative, isn't it? Okay, what's the GCF of x squared, x to the fourth, and x cubed? X squared. So the GCF, the negative GCF, is negative 2x squared. Okay, what's left? Yeah, now, I'm glad you guys saw that, because a lot of people would say, oh, there's nothing left from this guy. We factored the whole thing out. Technically, there's a 1 left, and it's not just being technical. It's important for when you distribute it back out to get the same thing you started with. If you didn't leave in that factor of 1, you'd only have 2 terms inside the parentheses, which wouldn't make sense. So you do have that factor of 1 left. And then from the first term, and then what else? What's the operation changed to? Minus 2. There's a factor of 2 left. And then an x squared. Does everybody see how we got that? Okay, and then what's the operation on the last guy? Plus, okay, you factor out a 2 from 12, you get 6. Factor out x squared from x cubed, that leaves an x. So you get negative 2x squared times the quantity 1 minus 2x squared plus 6x. Here's one a little bit weirder. You're asked to factor. Now, why is this not factored to begin with? We have the polynomial r, so this has 2 variables in it, r times the quantity t minus 3, and then minus s times the quantity t minus 3. Why is it not factored already? What's the problem? Well, okay, so you see a couple of factors in here, and you might think it's factored. But it's not, because it's not a product all the way through, is it? That minus in the middle makes it so this thing is not factored. So keep that in mind. Now, somebody said we need to multiply it out. Well, no, I don't think we do. So there's two, does everybody see that there's two terms defined by the products, r times quantity t minus 3 and the minus s times the quantity t minus 3? There's actually two terms in this polynomial. The terms are defined by the products, right? Now, do those two terms have anything in common? Yes, what is it? The quantity t minus 3. So we can treat the quantity just like we would treat any other variable or any other number. Since it's the same in both, we can undistribute it. We can factor it out. Imagine pulling the quantity out. So I'll pull it out on the right here, although you could pull it out on the left. Imagine, in other words, undistributing the quantity t minus 3 from both of the terms. And then what's left from the first term? If you take out the t minus 3, what's left? R. That's from the first term. That r is left, right? When you factor out the t minus 3. What's left from the second term? Minus s. And I made my parenthesis a little wide there, so I'll bring it in like that. So the answer is the quantity r minus s times the quantity t minus 3. Now, does it matter which order you multiply it in? Could you write t minus 3 first, the quantity t minus 3 first? Yeah, commutative property of multiplication says a times b is equal to b times a for any numbers a and b. So r minus s, that quantity times the quantity t minus 3 is the same as t minus 3 times the quantity r minus s. So in other words, we could have factored out the t minus 3 on the left side instead. Either answer works. Now that is half of factoring by grouping. That example we just looked at is half of factoring by grouping. Does everybody see it's just the distribution property? In the reverse from what you're used to, but it really is just the distribution property. Yeah? When you pull out that t minus 3? Okay. So you're undistributing.